NASA's Astrophoto Challenge lets you make your own space image using astronomy data. The 2024 Winter Challenge features the Crab Nebula, which has fascinated astronomers for centuries. Our history of this object dates back nearly 1,000 years, when skywatchers across many cultures observed a spectacular new light source in the sky, one so bright that it was visible even during the day to the unaided eye. Hundreds of years later, Western astronomers found a faint, fuzzy source in their telescopes in the same patch of sky. Further observations revealed filaments reminiscent of crab legs, inspiring the common name of Crab Nebula used today. It would not be until the 20th century that astronomers connected these two discoveries, shaping our understanding of the life cycle of stars. The bright object in 1054 AD was a supernova, and its aftermath can still be observed today.
A supernova explosion is one of the most powerful and energetic events in the universe. In a star much more massive than our Sun, this explosion occurs when the core of the star runs out of fuel and suddenly collapses under gravity.
The core suddenly collapses under its own weight, forming a neutron star, the densest matter in the universe. Anything denser than that, it's a black hole. When a neutron star forms, it generates a shock wave that explodes the star from the inside out.
What we call a supernova remnant is what remains of the star after the explosion. The layers of the star are ejected into space at very high velocities, and the surrounding material is heated by the explosion's shock wave.
We do observe supernova remnants expanding over time as the front of the shock wave sweeps out material. This process generates the most beautiful astronomical objects we can observe across the whole electromagnetic spectrum.
For this Astrophoto Challenge, you can explore and use data from multiple telescopes. Each dataset reveals something unique about the Crab.
The supernova explosion that produced the Crab Nebula left behind a pulsar in its center. This rapidly spinning neutron star that has a high magnetic field produces a wind of charged particles that emit radiation.
This is the Chandra observation of the Crab Nebula. It shows the fast-moving winds of particles that fly off the central neutron star, energizing dust and gas around it. We can see jets coming straight from the neutron star to then gently curve farther away from the central engine. We can see an inner bright ring surrounded by a thicker torus. The central neutron star appears darker. That is not a real effect. That is due to the high brightness of the neutron star in the center that we need to cover in order to see the structures of the nebula, which is fainter.
This ultraviolet image also shows the emission from the energetic particles accelerated by the pulsar, but these particles have a slightly lower energy and have traveled further out, and this is why the pulsar wind nebula at this wavelength appears larger than in X-rays. At visible wavelengths, the Crab Nebula looks very different. These filamentary structures that you see is the gas that was ejected in the explosion.
It shows the supernova remnant that surrounds the inner pulsar and pulsar wind nebula. We can see asymmetries in the filaments, as well as development of long fingers of gas and dust.
In the James Webb Space Telescope images of the Crab Nebula, we see the smooth emission from the pulsar wind, but we also see the very resolved, fine, detailed structures of the iron gas ejected in the explosion.
It also shows a synchrotron emission from charged particles interacting with magnetic fields in the nebula. Those appear as smoke-like material in the picture.
The ground-based micro-observatory provides a wide view showing the Crab Nebula in its surrounding environment. The universe is in a constant state of change, and the Crab Nebula is one place you can see dynamic changes yourself.
These are X-ray observations that reveal wave-like structures expanding outward from the heart of the exploded star. The waves look like ripples in a pond. This might be caused by a fast outflow from the neutron star going through strong variation in magnetic field strength.
Make an animation using Chandra X-ray datasets and look for motion in the flowing jets and ripples around the pulsar.
The Crab is among the most interesting and well-studied objects in astronomy. And yet, Every once in a while, it amazes us with new features that challenge our understanding of the entire class of these objects.
What I love about the crab is that one could spend an entire career studying it and never run out of questions to investigate.
The Crab Nebula has been an object of wonder for nearly a millennium. From the first human observations of the supernova in the 11th century to the evolving features unveiled by our most powerful telescopes today, it continues the story of the lives and deaths of stars and even connects us to our own origins in the universe.
Now, it's your turn to try NASA's Astrophoto Challenge.
Tell us about the colors you've picked. Were your choices scientific, artistic, or both?
We want to see what you've done.
Submit your results at the Astrophoto Challenge website, and your work might be featured as a standout entry.